Hello. We are going to continue on weekly contest 309 and do meeting room 3. Okay, so we get an integer n, and that n represents that we have n rooms that are numbered from 0 to n minus 1, right? And we get a 2D integer array meetings where each slot has start and end of a meeting. And this is a closed interval at the end, and so we have start and end not inclusive. And these values are unique. All the values of start are unique. And the meetings are allocated to rooms with these three conditions. So each meeting will take place in the unused room with the lowest number. So this is important, with the lowest number. And unused, so no other meeting is taking place in that room. And if we don't have any free rooms, right, then the meeting will be delayed, right, until one of these rooms becomes free. And those delayed meetings will still have the same durations, right? So we'll need to push end by how much the delay that we encountered, right? And then the last thing is that if a room becomes unused, so a meeting that was using the room ended, and so the room freed up, then meetings that have an earlier original start time should be given the room. So we should prioritize with the rooms that just became free, we should prioritize meetings that have the earliest original start time, right? And then the final goal is to return the number of rooms, is to return the index of the room that held the most number of meetings, right? After all meetings take place, which room had the most meetings, right? And if there are multiple of those that have kind of equal number of meetings, then we want to return the one with the lowest index. And that's pretty much the problem. So a lot of conditions here, but they all make sense. So if you take a look at this meetings and n equal to 2, so we have 2 available rooms. So the first meeting starts at time 0, right? And so both rooms are not used. So this meeting takes the one with the lowest number, which is from the first condition. And so it takes it starts in room 0. At time 1, for the second meeting, room 1 is available, and that's the only one available. And so this meeting takes place in room 1. And now at time 2, both rooms are not available. So both rooms are used, 1 and 2. Room 0, and 1 are being used at time 2. And so the third meeting, this one here, is delayed, right? And then at time 3, right, for this one, both rooms are still being used, because this one finishes only at 10 and this one only at 5, right? And so this one also gets delayed, right? And then at time 5, the meeting that took place in room 1 finishes earlier, right, than this one. And so it finishes, so room 1 frees up. And so the condition 3 says if a room becomes unused, so it frees up, we need to give it to the meetings with the earliest original start time. So between the 2 delayed here, the one that happens earliest is this one. And so the third meeting, which is this one, starts in room 1 that just got freed, right? And then at time 10, once room 0 frees up, we can do the last meeting in room 0, right? And so if you check which meeting took the most, which room held the most meeting, both 0 and 1 held 2 meetings, and so we return the one with the lowest number according to this rule here, and so we return 0, right? Yeah, so that's pretty much it. And if, let's say, room 0 held 3 meetings and room 1 held 2, we need to return 0. And so that's the idea. Now let's see how we can solve it. Yeah, so this problem is mainly keeping track of everything, because there is a lot going on, a lot of conditions going on here. And so let's just do it slowly. So what do we need? we definitely know that we want to keep track of the unused rooms, right? Which initially the unused rooms, it's all the rooms, and so that's just I for I in range of n being the number of rooms, right? And the other thing we want to track, because what we are looking for actually is at the end is the index of the room that held the most meetings. So since the problem here, what we want to return is the number of the room that held the most meetings, we need to keep track of how many meetings were held in a room. So basically we want to keep track of the usage of a room, right? And initially it's 0 for all of them. So 0 for all the rooms like this. Okay, so that's one thing. Now for the unused rooms, the other condition we have is that each meeting will take place in the unused room with the lowest number. And meetings like the rooms will assign one a meeting and then remove it, right? So that it's not. So for unused here, basically the operations we need is remove, because once we place a meeting in a room, we want to remove that room from the unused. But the other thing is also like in the list of unused rooms, we want to always, for each meeting, pick the lowest number. So which means here we want to get smallest, right? And so if you take a look at these operations, what we need is a priority queue, because these are more efficient with a priority. Especially smallest is more efficient with a priority queue. And so let's use a priority queue, which means once we initialize the list here, let's heapify it. And so we heapify unused. Okay. Now the other thing we need to keep track of is that if once we place a meeting and there are no rooms available, next meetings will be delayed until one room becomes free. So we need to know when a room becomes free, right? And when does a room become free? It's when the meeting that was in it is over. So we need to keep track of that information. So let's keep track of at the time a meeting will be over, because that would mean a room frees up. And so to do that, we'll keep track of meeting over here. I'm going step by step and just defining basically everything that we need. Instead of giving the whole idea, just because it's going to be tough to give the entire idea in one sentence, right? So what should we keep in this meeting over array? We definitely need like the time of the meeting end, the time the meeting will be over, because that's the time when the room frees up. And we need the index of the room that frees up, right? So basically this would be, and time would be time when meeting is over and room frees up, right? Okay, and now we know that the other thing is that we know here, according to this, is that when a room becomes unused, meetings that have the earliest original start time should be given the room. So we want to start with the meetings that have the earliest start time, which tells us here we need to go through the meetings in sorted order, right? So we need to go through them in sorted order of meetings. And here this would give us start and end. Okay. And then here we'll need to do something else here, so I will mention it. But first, we know that if there are unused rooms, so here basically this means that the length of unused is bigger than 0, which means we do have at least one unused room, right? So there is an unused room available. Unused room available. That means we can just take that smallest room. So the problem says always pick the smallest room first. And so to get it, we just take unused. And since it's a priority queue, we can do heap queue dot. So we can use heap queue dot heap pop to get that unused, to get that smallest room, right? So that and extract it. And now once we have it, we want to place the meeting in it. And so the only thing we need so place meeting in room, right? And so we need to record when the meeting will be over, so that for the rest of the meetings, they can know when this room would be available, right? So we would have meeting over, and we need to make also this priority queue. Why is that? Because we want to place the meeting in the room that frees up the earliest, right? And so we want to make this also a priority queue, so that we can extract the smallest end time, which means the room that frees up the soonest or the earliest, right? And so what this would mean here is that we will need to also push heap queue dot heap push to this one. We want to push what's the end time, right? So the end time is just this end here, right? And what's the room? So this is the pair that we'll push. The room index is just this, so that's what we want to add here. Okay. And this will also have the benefit that if both end at the same time, we'll pick the smallest room, right? Okay, and now here, this means basically no room available, right? Which means the meeting needs to be delayed. Okay. And so here we don't want to keep track of the delayed and then go back to it and fill it again. What we can do is just check, since we added previously, we added when the room would be available. We can just check when it will be available, when the earliest room will be freed. And so we would do heap queue, heap pop, and we will extract from meeting over. And this will give us a time when when the earliest room would be freed up. And so time room, and we can place our meeting in the room that will be freed up the earliest, right? And so to do that, well, we just push, again, to place, we just push the meeting over, right, for the next meeting again. And so this would mean what should be now the ending. So the ending, because we didn't place this meeting at start time, we placed this meeting at this time, right? And so the duration here, we need to get first the duration of the meeting, which is just the end minus start. And the end of this meeting would be this time, because this is the real time it started at, because that's the time when the room that we want to use freed up. And so we would take time plus this duration. That's the end time, right? Because this meeting will take place only once the room frees up, which is at this time. Okay? And it takes place in this room that was freed up, right? And something we don't want to forget, because that's the goal of the problem, is to return the index of the room that held most meetings. So we need to record the room that held this meeting. So we can either do it in every if here, so we can do usage room +1, right? Because we used it, we placed the meeting in it, and do it here, or we can just do it outside of the if, because we do it for both, right? And room will be assigned in both. Okay, and now there is one step missing, which is we want to release any room that got freed up because the meeting is over before the start time, right? So what does that mean? So we want to release any room that was freed up before S, right? Because here we do it, we take it only if it was freed up after S, right? So here we want to any room that was freed up before S, because the meeting that was in it was over before S, we want to free it up. And maybe there are multiple of them, right? And so we want to do while meeting over. And how do we tell that it's smaller than S, freed up before S? Well, we just need to access the end time, which we can access. First, what is the smallest? So that's 0. And what is the end time? That's 0. And how do you check if it's smaller? We just say this, right? So this would mean that this meeting that was in room that is in this second place of the pair, this meeting was over before the start time of the meeting we are looking at right now. And so what this would mean is that let's push it to unused room because the room that this meeting was in got freed up. I hope that's not confusing. And so we will place it, we will add it to unused because it just got freed up, which means we need to push it because unused is a heap, right? And so what we do is heap q, heap push. In unused, we want to push the room, which is, let's extract it. So we want to completely extract it from meeting over. So this would be heap q dot heap pop from meeting over. And this will give us the room and the end time, and we want to push the room to unused. We know, so this time here, this is what we are comparing against S, right? And we'll do this for all those that got freed up before S. That way in the here, if there was any room that was freed up before this S, we will just use it right away here, right? And yeah, that's pretty much it for like the simulation process. Now, once we have usage room, we want to find the one with the highest usage. How do we do that? It should be pretty simple. We just need to keep track of the best room. So initially, let's just say it's 0. And we'll go through each room and check if it's the best usage. So if the usage of best room is smaller than the usage of the one we are currently looking at, that means I held more meetings than best room, so we need to assign best room to I. And then at the end, once we traverse all the room and compare against, we return best room. Okay, and that's pretty much it. Let's just make sure we heap q here. So heap q. Let's use more examples. Let's submit. Okay, so that passes test cases. Yeah, so pretty much the main idea is we are using 2 heaps, one for unused and one for meeting over, and we are just doing a simulation process. And yeah, with this problem, you just have to be careful of just making sure you do the simulation properly. And we record the usage for each room, and then at the end we give the best room. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.